Okay, today in class we're going to look at how to use the graphing calculators a little bit along with this lesson. It says a raft floats down river at 9 miles per hour. The distance y the raft travels can be modeled by the equation y equals 9x, where x is the number of hours. Make a table in the graphing calculator to find how long it takes the raft to travel 153 miles. So in order to be able to do this, you've got to know how to use the calculator. There's a button up here called the y equals. If I go to the y equals, it allows me to type my equation in. So I'm going to press 9, and then right here beside the green alpha button is the x button. So I've got my equation y equals 9x. So if I want to graph this, I can just go ahead and hit the graph button, and it gives me a graph. Sometimes your calculator might not be set in such a way that it gives you the appropriate graph. So next to the y equals button is a window button that allows me to change the window. So let's say that I don't care about what's below 0 on the x-axis. So I want to change that -10 to a 0. And I've got an x maximum value of 10. So that means on my window it's going to show from 0 to 10, and the x scale means that it's going up by a unit of 1. Then this x min means that it's -10. Well, I don't really need that either. Let's just look at 0. My x maximum is going up to 10, and then my y scale is 1. So let's look at the graph now. There it is. Since our x is growing by 9 at a time, let's go back to that window and change our x scale to 9 just to see what it does. And let's go with a bigger number. Instead of going with 10, let's go by like 80. Oops, that's 880. We don't want to go that big. Okay, so let's look at the graph now. Interesting. I can't even see anything. So let's go back. That wasn't a very good window to choose. Let's try an x minimum, our x maximum. Let's look at the y scale increasing by 9 and going to 80, and let's see how that changes things. Let's go back to 1 and 10. Now let's look at the graph. It changed the steepness of my line. Okay, so let's go back. There's another feature that I really want to show you. Let's go back to our window of -10, 10, 1, -10, 10, and 1. Go back to our graph, and then there's this other thing. If you look above the graph, there's this blue word, table. So in order to access that table feature, I have to hit the blue second key and then hit that graph button. And it gives me a table of values. So it tells me that when x is 0, y is 0. Remember, x is the number of hours. So if I've traveled for 1 hour, then I know I've traveled a total of 9 miles. If I've went for 2 hours, I've traveled 18 miles. If I traveled 3 hours, I've went a total of 27. So we want to know, when will I reach 153 miles? So let's look down here. When does it get to 153? 17 hours. So when 17 hours has passed, I have traveled a total of 153 miles. So that's exactly what we want to do today. You can use your calculator to be able to access these features, but we want to look at using tables, equations, and graphs to describe relationships. And this goes along with the standard of understanding that the graph of an equation in 2 variables is the set of all of its solutions plotted in the coordinate plane, often forming a curve. Okay. So let's just jump right in. A solution of an equation with 2 variables, x and y, is an ordered pair, x comma y, that makes the equation true. I always remember which one comes first by looking at the x and the y. In the alphabet, x comes before y. So in my ordered pair, x comes before y. And if you look at the graph, we know the x-axis is our horizontal axis. The y-axis is our vertical axis. So if I want to plot x comma y, I go over whatever the value of x is, and then up to whatever the value of y is. So in this problem it says identify solutions of 2 variable equations. So we have an equation with two variables, and I'm wanting to identify whether this is a solution of this equation. So is 3, 10 a solution of the equation? Remember, 3 is just the x value and 10 is just the y value. So what I'm going to do is I'm going to take that 3 and I'm going to place it in place of x, and I'm going to put that 10 in place of y and check to see if it's true. Obviously, it is not true. We know that 4 times 3 is 12. So therefore, 310 is not a solution of the equation y equals 4x. If you want, you can pause the video at this point and go ahead and try the next two on your own to see if they are solutions of the equation. So I'm going to plug in my 20 in place of my y, plug in my 5 in place of my x. 4 times 5 is 20. So yes, 520 is a solution of the equation. Let's try it again. 4 times negative 5 should equal negative 20 if this is a solution. A positive times a negative. Think of the song. Multiply or divide, it's an easy thought. Same signs are positive, but different signs are not. They're not positive, therefore they are negative. And negative 20 is equal to negative 20. So negative 5, negative 20 is a solution to this equation. You might be thinking, well, I thought this was a solution, so why is this a solution? If you think about it, this is a linear equation. I've got a slope of 4, so it's going to look something like this. So of course, there's going to be lots of ordered pairs that are solutions. Any ordered pair that falls on this line is a solution of the equation. If it's off of this line somewhere, then it's not a solution to the equation. But as any of these points that fall on this line, and this line could keep on going down forever in this direction, it's going forever and ever. Any point that falls on that line we know is a solution to this equation, meaning that I have infinitely many solutions. Okay, so there's lots of ways that we can represent the same relationship between two variables. For example, you can draw a table, you can write an equation, or draw a table, I guess you could draw it. You would write out the table, draw a graph, write an equation. So look at this problem. If you want to pause the video and try this problem on your own, that would be great. Both Carrie and her sister Kim were born on October 25th, but Kim was born 2 years before Carrie. Key indication here is Kim was born 2 years before Carrie. How can you represent the relationship between Carrie's age and Kim's age? Well, first, the best thing to do would be to find our variables. So let's let x equal Carrie's age. And let's let y equal Kim's age. So now if you think about this, if Kim was born 2 years before Carrie, Kim was 2 years when she was first born. Well, when you're first born, you're 0 for that whole first year of your life. You hear parents say, oh, she's 1 month old, or she's 2 months old, she's 3 months old. Then after that first year, they finally turn 1. So when she was just born, just a few months old, Kim was 2. When Carrie was 1, if Kim's 2 years older than her, then we know she is 3. And we can keep on going in this manner. 3, she would be 5. 4, she would be 6. 5, she would be 7. If she's 6, she would be 8. So now what I want to do is I want to think about an equation. We want to relate y and x. So if when Carrie was 0, Kim was 2 more than her. When she was 1, Kim was 2 more than her. When she was 2, Kim was 2 more than her. So if I know Carrie's age and I add 2 more years to it, then I'm going to know Kim's age. And if I want to graph this, you can use the graphing calculator to type this equation into the y equals, or you can just simply plot your points. When x is 0, y is 2. When x is 1, y is 3. And it's going to keep on going forever in this direction. Okay, inductive reasoning. It's something that we use every day. My belly's growling. I'm hungry. That's inductive reasoning. I don't know, a boy hits on you in the hallway, you might think that he's got a crush on you. That's inductive reasoning. It's the process of reaching a conclusion based on an observed pattern. You can use the inductive reasoning to predict value. So I'm looking at this pattern here. I can see there's clearly a pattern. I've got one blue one, then I've got two blue ones. The next set I've got three blue ones, so I can assume that in the next one I'm going to have four blue ones. So to extend the pattern, I want to know what is the total number of tiles in a figure with 8 blue. So let's think about this. When I have one blue tile, there's how many tiles altogether? We can see there's 9. If I have 2 blue, there's 9 and 9 more, making 18 altogether. If I have 3 blue, there's 27. If I have 4 blue, there's 36. And it keeps on going forever in this pattern. If I look at what's happening, it's getting larger by multiples of 9. This 9 times 1 is 9. 9 times 2 is 18. 9 times 3 is 27. 9 times 4 is 36. So I'm expecting each one to keep getting bigger in this same pattern. I had one blue one, 9 total. When I had 2 blue ones, I had 9 and 9, so I had 18 total. So if I have 8 blue ones, I'm going to expect to have 9 times 8, which is 72. So let's write a generic equation to represent this in terms of x and y, where x is the number of blue and y equals the total number. So in this pattern, when I had 1 blue, I had 9 total. When I had 2 blue, I had 18. Here, if I have 8 blue, which I'm letting x represent my blue, I had 72 total. So I want to let y represent that and then keep my 9 the same. So my equation is y equals 9x. So when I have 0 blue, I have 0 altogether. When I have 1 blue, I have 1, 2, 3, 4, 5, 6, 7, 8, 9. When I have 2, I have 18. And there is my line for my equation. That is a horrible line, but you get the idea of it. So what I want you to do now is go to the Google Classroom, and there is an exit ticket on there. If you did not get that finished in class today, please log on and finish that now because it is for a grade.